Thank you. Thanks for the introduction, and thanks everyone for coming. My name is George Gui. I'm an assistant professor in marketing at Columbia Business School. And this is a joint project with my amazing colleagues, Olivier Toubier, who is at Columbia Marketing, and Ken Yipeng, who is at Columbia Business School Operation, and Daniel, who is in pre-doc, and Leon and Tony, who are undergrad CS students who help with a lot of engineering work for this project. So this is a non-standard research project because for a lot of research projects, especially for empirical work, we first collect data and then conduct a lot of analysis, extract insights, and then publish it. So this project is primarily about data, or is mostly about sharing a data set, and we have already submitted and got accepted at Marketing Science Database Submission. And I'm going to, the purpose of this talk is I will describe this data set to you and hopefully convince you that this is a useful data set for us to think about the development of digital twin and the evaluation of different methods, and hopefully this can contribute to the advancement of the field in terms of using large language model to simulate human behavior and evaluate different methods and pros and cons. So this is an overview of this, what we're trying to do for this data set. So this data set includes around 2,058 individuals. We have collected more than 500 questions per individual. And overall, the data set has high accuracy. And later, I'm going to walk through what kind of data questions we have collected and why this can help us with evaluating different kind of methods for simulating digital twin. So the background, I think with this audience, I don't have to talk too much about that there's a growing literature and growing a number of people who are working on this area in terms of using large language model to simulate human behavior. Typically, we employ generative models to evaluate LLM's ability to simulate human behavior across different domains. And also, right now, there's an increasing number of work that focuses on digital twin simulation in the sense that we are providing more information about an individual, and we're curious about, suppose that we have collected so much information about an individual, whether we can predict what is going to happen in a new environment. And that is going to be incredibly useful for researchers to evaluate how a new experimental stimuli is going to change the participants' response, or for firms in terms of evaluating how a different intervention is going to work out. So this can be extremely helpful. But at the same time, this literature, I would say that the results are quite mixed. So some argue that LLMs, the results show promise based on certain metrics, such as correlation, accuracy along certain dimensions for a certain domain. And others argue that these metrics are not good enough. And LLM simulations have some important biases, so they're still not going to be comfortable using these models. Here's an example of a mixed result. So this is a paper from Hewitt 2024. And on the x-axis is the treatment effect predicted by GPT-4. And on the y-axis is the actual treatment effect run using real human data. So this is an example of a mixed result because if you look at the graph, you see that there's very high correlation, meaning that on average, if the treatment effect is high for actual human subjects, then the LLM is also going to predict that the experiment is going to have high treatment effect. But if you look at each individual point, it is quite far from ground truth. And then there's a question of, if you are a researcher who are conducting the actual experiment and the paper is about the experiment, how comfortable will you be of using LLM to substitute or augment your actual experiments? So this is an example of a mixed result. And overall, I would say that there's a lack of consensus on the ability for LLM to simulate human behavior. And there are a lot of questions that are remained unanswered. For example, does it really work? Does this method of collecting data about an individual and predicting what's going to happen in a new scenario? Does it really work for LLM, including out-of-box LLM or fine-tuned LLM? What types of behavior can digital twins predict? What type of input is needed to create digital twins? Because that's also a very important question in terms of if we want to simulate individuals realistically, what are the set of questions that we should spend a lot of effort collecting? And how should digital twins be built? Because there's a lot of degree of freedom, which means that there's a lot of opportunity for research thinking about like new methods that can build digital twins more effectively. So there's a lot of degree of freedom and opportunity here. And of course, the answer to these questions depends on what specific domains we're studying. For example, like we as social scientists are interested in consumer behavior, psychology, and cognitive behaviors. And so this data set is trying to help answer these questions because we think that answering these questions in terms of whether digital twin is going to work and what kind of methods is going to improve its ability to simulate human behavior depends on a lot of factors in terms of whether we have gathered a rich data set for us to evaluate the models or the methods ability. So first, we need a data set that has rich individual level behavior that ideally include detailed characteristics to test persona-based approach, because one very popular method that we use to simulate human behavior is we're going to assign individuals with a certain, or the simulated individual with a certain characteristics, and then ask how is it going to behave in a certain scenario. And the value of providing the detailed persona characteristic is that we can make this simulation more realistic, and there are research that has documented that indeed when we are providing additional detailed individual characteristics, we see like more realistic individual behavior as well as more diverse response. So including detailed characteristics is valuable for us to evaluate the ability of digital twin. And it's also helpful to include multiple cognitive and behavior experiments per individual because like a method that works in one type of experiment may not work for others. So like including a wide range of experiments in the data set can be helpful for us to evaluate on average what is going to be the performance of a certain method or a certain type of questions. And it's also helpful to think about common evaluation metrics that would provide a standard benchmark for comparing different methods and track field progress systematically. For example, like one obvious question is maybe since 2023, there has been papers on using large language model to simulate human behavior. But like we don't have a good sense of, okay, as LM models have become better, is our ability to using them, is the simulation more realistic over time? Or is it going to like improve on certain domains, but not improving on other domains? So like without such a large data set, we are not even going to like have a good sense of is the model improving or not, or is our method like improving the simulation or not? And this is why we are like we want to like open source and share this data set. So this data set includes more than 2,000 people, each answered over 500 questions, covering demographic questions, psychological tests, cognitive tests, economic preferences, heuristic and bias experiments, and product preferences questions. So now you may ask, of course, this sounds a lot of questions. Do participants have enough attention span to answer all of them? To deal with this issue, we split the questions across 4 waves. So the initial sample is around 2,500 prolific participants, and we asked Prolific to make the sample representative based on the age, sex, and ethnicity. And there's a total of 4 waves, and the first 3 waves are 1 week between each, and then there is a longer gap for the wave 4, because what's special about wave 4 is that we are repeating some of the questions that we have asked before. And we think this is valuable because we know that sometimes the quality of the survey may not be so good. So it's valuable to like have some retest accuracy benchmark. So the total time that survey participants spent for the survey is around 2.42 hours on average, and got paid $37 per participant. And this is like we pay, we kind of incentivize them to continue to take the survey, and that's why like we have a pretty high completion rate, I would say. So the inbound sample is 2,500 participants, and a month later, there's still more than 80% of the people have completed all of the 500 questions. So due to the time limit, I'm going to quickly go through some of the characteristics of the data set and some of the promising like why it is useful. So first, it has covered a comprehensive range of questions, including demographic questions, personality traits such as Big Five personality, and cognitive abilities such as reflection test, fluid intelligence test, and economic preferences such as ultimatum game, discount, present bias, risk aversion, and heuristic and bias, including the base rate problem, outcome bias, sunk cost fallacy, and product preferences, which is another paper that Olivia and I worked on the people's price sensitivity and demand curve. And so like one benefit is that the dataset has a wide range of questions, and then the other benefit is that it replicates established effects and correlation, which kind of support that the dataset is of reasonable quality. So one measures that we extract is because we have such a wide range of measures, we can calculate the correlation between different characteristics and see if they're reasonable. And here are some examples of significant correlations between different measures. For example, you see here that the need for cognition score is correlated with openness score, and the age is positively correlated with self-concept clarity score. So this just kind of suggests that the data is of reasonable, give reasonable correlations. And also, it is able to replicate some of the well-known experiments. So because we are using the same questions that were conducted in prior experiments, we can test whether our survey actually replicates the prior experiments. And you see here that there's only one case where the survey does not replicate a prior experiment, which is Kahneman Tversky in 1973. And in all other cases, our survey has replicated the classic between subject experiments. And for within subject experiments, we have also almost replicated all of the studies we have included in the survey when we compare to the prior published papers. And the other benefit is that we have a built-in benchmark that kind of establish what is the test-retest reliability, and that can help us to get some idea of what is the potential ceiling of using large language model to simulate human behavior. Because if human answers themselves are even not consistent, for example, if it's random all the time, then it's just hopeless to try to use large language model to simulate that. And so the way that we conducted is that we select some questions that we ask, especially for between subject and within subject experiment questions, and then ask the same questions in wave 4. And I'm going to skip the creation of the digital twins in terms of how we exactly implement it. There's a lot of engineering work involving converting the Qualtrics and the raw response to a text or JSON format that can be easily processed by the LLM. But here is like an overview of the initial tests using different methods. So the random guessing is the benchmark is around like 60%, and the improvement by using the persona approach is around, we can increase it from 60% to around 70% accuracy. And so like the method, different variation of method changes a little bit, but overall it does not change the accuracy that much, maybe like by 1% or 2%. This is some initial benchmark that we have. The key challenge that we found was that although the performance is reasonable at the individual level, and is actually, if you compare to the test-retest accuracy, it achieves around 87% of the test-retest accuracy. So this is also consistent with the results, for example, in another Stanford paper and other related paper. So the individual level accuracy is promising. But what we found was that, at least so far, based on the list of methods that we have tested, it has some challenge replicating or simulating the between subject experiments and also within subject experiments. So here you see that the digital twins were not able to replicate base rate problems, outcome bias, sunk cost fallacy, anchoring and adjustment. And for within subject experiments, it's also not able to replicate around 50% of the experiments. So this just shows that one possibility is that there is some inherent challenge of using large language model to simulate human behavior, but the other possibility is that there are some difference in design that we have to pay attention to when the goal is to use a large language model to simulate an experiment, regardless of between subject or within subject experiments. And due to the interest of time, I think I'm going to skip some of the observations. If you're interested, you can read the paper. And we also have a work in progress that we are collaborating with other faculties at Columbia that tries to launch a new wave of experiments that they are interested in studying and see how it works actually. And just to summarize, the data set includes around 500 questions and 2,000 respondents. The evidence suggests high data quality in terms of sensible correlation pattern, good retest reliability, and replication of known effects. And the initial test is promising at the individual level, but at the experimental level, it may be some problematic. So feel free to reach out to us if you are interested in using the data set or if you have any other questions. Thank you so much.
Mm-hmm. On the part that was inaccurate,
yes.
Are errors like, what does distribution look like? Is it like, we know how to do errors with statistical normal distribution. What does the error look like when you use LLM to do this? What does the error look like?
Yeah, I would say it depends on the exact questions and also depends on the type of question, because some of our questions is binary, then just it's from a binary distribution. Like one interesting thing that we found is it depends on the question. For example, like for some questions, like LM seem to have a hard time unknowing facts. For example, for like the factual questions such as the number of African countries in the United Nations, LM will give the correct answer 98.8% of the time, but only 10% of the human will give the correct answer. So this is an example where it depends on the unknowing facts, and also sometimes it depends on, for example, whether the question is related to medical profession or is related to whether it's conservative or liberal opinions.
I guess I'm just like, is it when it could be very highly accurate,
mm-hmm.
but when the answer is wrong, it can be catastrophically wrong. I'm just curious if you can comment on it could be very accurate, it's great, 98%, but with 2% are wrong, it's not off by a bit, off by a lot. That's kind of what I'm imagining.
I see. Yeah, I would say that in general, it is, first, for binary questions, there's no astronomically wrong. For continuous questions, we haven't checked, but feel free to explore the data set. Yeah.
Thank you.
Yes.
So the personas are really big, right? This is awesome that you have all these surveys.
Uh-huh.
But are the LLMs actually taking advantage of all the detail from the persona?
Uh-huh.
So because that's a lot of context.
Uh-huh.
In terms of a persona,
mm-hmm.
and it's an interesting question to me to seem maybe actually it's better to have a smaller, more compact persona
mm-hmm.
rather than this extremely large persona.
Mm-hmm.
Have you looked at the effect of the size?
Yes, that is a very fair question. I would say that is also a part where there is a lot of degree of freedom, because suppose that firms or researchers have access to a wide range of persona detail, what would be the most efficient way to incorporate them to make the simulation more realistic? So in our case, we have explored either using the original question, which is 500 questions, or have a more detailed summary of the scores. And we did not find much difference. I would say that using all the information is slightly better, but there's a question of whether it's worth it given the extra token cost. But on the other hand, we also did not find that the summary is outperforming the detail. So this suggests that LM still has some ability to kind of incorporate the long context, because we know that the model has been developed and its ability to process long context is also being increasing. Yeah. Yeah. Arthur?
Yeah, Josh, I have a couple of questions about the product questions which are very related. One is about, do you have any incentive compatibility in answering those questions about product preferences?
Uh-huh.
And the other, which is kind of related, there's a growing concern
Mm-hmm.
in the product development community that people, instead of humans answering those questions, people on Prolific would be using
Yes.
agentic AI to respond to those questions.
Yes.
And so out of those 2,000 people,
Yeah, that is a very reasonable question. We also thought about it and we were afraid of it. So like one way that we try to like evaluate and track of the potential concern is that we have a string tracker and tab tracker, so that if the participant has moved to another like tab, then we will find that we'll find the time it takes and how many times they have moved. So if some participant is like moving very frequently, then that may suggest that they may have, like for each question they just screenshot and then get the answer. But we haven't found many cases like that. For the first question that you had. About the so that is also like a reasonable question in terms of the incentive compatibility, right? If we have enough money, of course we can make it more incentive compatible. In our case, the way to deal with that, because we are really having a wide range of questions, so it's really unclear how do you like for each individual study to make it more incentive compatible. But we have a test-retest reliability benchmark, so that can help us to evaluate how challenging it is to inherently get it correct.
And at the end, when you went to this 2,000 people sample, how many people have you screened out?
How many
people were screened out? Like, what was the percent of people that actually passed your kind of screening and attention checks?
So the remaining, all the 2,058.
Okay, but the initial sample was like this is 2,000 out of 10,000 or 2,000 out of 2,500?
I have to check on this, but I remember we did not like sample a lot of the response rate is pretty high and the completion rate is pretty high. Yes.
Just to follow up that point, is it possible for you to segment your samples? For instance, people with similar big five personality in the same socio-economic group, then give them a purchasing task, looking at their performance versus you randomly draw from other groups and see their performance with the same purchasing like a scenario. If you can prove you can segment your sample, it gives you a better performance and you randomly draw from the sample. I think that would be very valuable for all the companies. So they will.
So by segmenting the sample, you mean like to focus the analysis at the segment level and then compare whether it's different across the segments, or
yes.
like.
So for instance, certain people have similar big five personality, they have same education level. I don't know whether your data have geographical location.
Yes.
So basically, you can proxy their income level and social status versus just random group.
Yes.
And then you can give them the same purchasing task.
Yes.
And then you build this digital twin, you're looking at the results.
Yes.
So you can also measure a lot of preferences, all the purchasing related questions, attitude, perception, purchasing intention, measure those and then compare to a random group from outside your segment.
Yeah, that's definitely doable with our data set because we have detailed information on demographics and other characteristics.
I think that would be very
Yes.
So the tests that you have, the cognitive, the psychological, demographic, are those psychometrically validated instruments or just questionnaires?
So those are not random questionnaires. Those are like we took the exact same questions from the published papers and then used them.
So you didn't split them up. I thought I heard you split up some other questions because there were too many.
No. All the questions are taken from published papers. We did not like invent new questions.
No, I mean, like they're asked in the same order.
Yes. Yeah.